Hi everyone, I'm Andrew Hoffman, a software engineer, security researcher, and technical author based out of the Pacific Northwest. Today, I'm going to explain to you the mechanics behind stored cross-site scripting attacks, to the point at which you should be able to go out and make use of stored cross-site scripting attacks in order to win bug bounties and test your own applications. So what is a stored cross-site scripting attack? Well, a stored cross-site scripting attack is just a variation of a cross-site scripting attack in which the payload is stored in a database. It doesn't necessarily have to be a database. There may be other places where this payload could be stored, but generally speaking, it's a database. The other variations could be something like a file system. But 9 times out of 10, what's going on is you're going to find script execution, and by the nature of the application logic, that script execution is going to be stored on a server so that you don't have to distribute it. The application will distribute the attack for you. Now, what does that all mean? So we're on level 2 of Google's cross-site scripting game, aka the game or challenge that Google created to test bug bounty hunters, white hat hackers, and security engineers. And level 2 is called persistence is key. Now, persistence is what makes stored cross-site scripting different than other forms of cross-site scripting. So here we have this application called Mad Chatter, and it's a group chat application. Now, we notice that down here we can share a status. Let's share test, and the status is reflected back at us in this little text blurb. But not only is it reflected, if we reload the page, it's still there. In other words, it's been persisted. In order for it to be persisted, especially if it persists across browsers and devices, that means that there's a server somewhere that is actually storing that data. But storing data does not make script execution. It does not make cross-site scripting. So what do we have to do to get this to become a payload that we can use to hack other users' devices? Well, in this case, it's actually pretty simple. In the previous video on reflected cross-site scripting, we talked about how if we decided to put a tag inside of a payload, for example, we'll do a heading tag here, we'll call it test2, and we submit that tag, and the tag is interpreted as an HTML element rather than text, which it is in this case. The browser DOM spec, which is a spec maintained by an organization called WhatWG, says if it looks like an element, treat it like an element. H1 is an element. So what happens is this string, which is sent to the server, looks like an element. It's treated like an element when it hits the browser, so it gets converted into an element, in this case an H1 tag. The next step is, well, everything inside of that H1 tag needs to be rendered as if it were an H1 heading tag, which is the case. As you can see that there is a line break below this H1 tag. There is also a differentiation in the font size. So in this particular example, the browser is not escaping this text. It is injecting it into the DOM as is. And the DOM is just doing what the DOM is supposed to do, interpreting elements or things that look like elements and saying, oh, this looks like an HTML element. Let's treat it as an HTML element. Now, that's not always the worst thing in the world. When it comes to security, it is, but when it comes to functionality, there are some legitimate use cases for this. For example, you may have an application where you actually want a user to be able to customize the way that their text looks. But if you don't properly escape and avoid the pitfall of allowing them to just put whatever they want in there, well, they can start doing things like this. So here we have an image tag. This is what we did in the reflected cross-site scripting example as well. This image tag, the src, the image we're pointing to, is X, which is not a valid URI. Because it's not a valid URI, we can put an on-error attribute, and we can say alert. Now alert, an on-error attribute, can point to either a JavaScript function that is already defined in the page, or it can just point to a built-in browser DOM function or JavaScript core function. In this case, alert is a browser DOM function, and if we share our status, you'll see that script execution occurs. Now, what does that mean? Well, what that means is if we inspect this, even though we sent text back to the server, when this page hit the client again, so when someone loaded into this, say we submit this message, somebody else loads up their chat app and loads in the same message, well, this text is going to get injected in the DOM. The DOM looks at it, says, oh, this looks like an image. I'll treat it like an image. Now, if it's an image and the SRC is invalid, we look for an onError attribute. And if that onError attribute has script, we execute it on the fly immediately when the image loads into the DOM. So that's how the script execution occurs. Now, why is this dangerous? This is dangerous because cross-site scripting attacks are not, they're running code that is not developed by either the user using the application currently or the application owner. So the application owner can run whatever script they want as long as you're on their website, and that script is contained by the browser. It's isolated, so it can't interact with the data and the functions from other websites. Only the stuff that that particular website owner produces. Now, you as a user could also run script, but there's no reason that you as a user would want to steal your own data. So yeah, you have access to all the data on this page. You could hit the servers and you could get additional access using your auth tokens, but there's no reason you would target yourself. Now, because this user is able to persist this script, and this script will run on every user who opens up Mad Chatter, that's where the danger comes in. Because imagine this isn't a chat app. Imagine this is a banking application. Now, this script could be, rather than alert, this script could be something like document.querySelector. Let's look at current balance. And then we assign that to something like, let's just say like balance. Well, now we know the script execution has taken your current balance in your banking app, put it in a variable, and oh, well, we can now do an XML HTTP request. And now we can hit our server with this current balance data. Oh, we have information on you we're not supposed to. Even worse than that, we can make requests to the server using your auth token. So if this financial application allows us to transfer funds, well, the script is executing on behalf of you, the user, and on behalf of any other user that opens this page and executes the script. Now their funds could be compromised. So stored cross-site scripting is a very serious attack. It's a very easy attack, not necessarily to get, but to spread, because in a lot of cases, the database, the application itself that draws from the database is spreading the attack for you. So in the case of this chat app, as long as we can get script execution, stored script execution, aka stored cross-site scripting, all we have to do is make sure a bunch of other users are using the same chat application. They open this chat thread, the script execution occurs, and with one payload, we can steal the data and modify the accounts of many users.